Hello viewers, this is Ved. Today I'm having the problem from the SS Krotov 1.2. I hope you have seen my last video about the problem 1.1. Okay, so this is the question, guys. Okay, if you want, you can pause the video here right now and you can try. You can give your shot to solve this problem. Now guys, I am going to solve this problem from my side. So here guys, let me read the question formally once. So guys, it is saying that of at a distance of L equal to 400 meter from the traffic light. Okay, so let me make the guys what a figure for you so that we can see that what is going on here, what they are talking about. So guys, let's say this is our traffic light. Okay, this is our traffic light. So from here guys, at 400 meter, so let's say guys, this is what 400 meter. Okay, uh, from the traffic light, brakes are applied to a locomotive moving at a velocity of what guys, v is equal to 54 kilometer per hour. So guys, of course there is a locomotive. Okay, locomotives are guys, it's an old word for the trains. Okay, so uh, guys, it is given that it is having a speed of how much, 54 kilometer per hour, which we convert if in the meter per second, it will be what guys, 15 meter per second. Now guys, further what it is saying, determine the position of the locomotive relative to the traffic light. Okay, determine the position of the what guys, locomotive relative to the traffic light 1 minute after the application of the brakes if its acceleration is what guys, minus 0.3 meter per second square. Okay, so this is the question guys. So guys, we want to find out the position of the locomotive uh, from the traffic light guys. So it looked like a very simple question, and actually it is a simple question, but there is something very what we can say humorous in this question that has been put by the author. Okay, so if you see guys, what is the humor that I want to show you. So if you see guys here, if I say that we know that guys, that final position of the particle generally, like how do we approach a problem. So if you see guys here, what we are going to do, we will do like this, that okay, time is given how much, 60 seconds. So this is given guys, t is 60 seconds. So at this position, what would be the position of the particle that has been asked. So guys, what we will do, usually what we will do guys, we will see like this, that s is equal to ut plus half at square. So s is equal to what guys, s always gives us what, displacement. So u is how much guys, 15 into 60 minus half into 0.3 into what guys, 60 into 60. So see that what kind of a problem is going to happen here. Okay, so guys, if you see that if I solve this, okay, what I'll get that it is 15 into 60 is equal to what, how much guys, this is 900. And then guys, what is going to happen here, this is 30. So guys, this is uh, I think 540. So this will be how much guys, this will become 540. So this is 60 and then 360 guys. Okay, so according to us, the position should be what guys, at this should be displaced by what, 360. So guys, 360 should be the displacement. So what we will say, that the particle maybe have gone to what, this position, which is what, this is 360. So the distance from the this position should be what guys, 40 meter. Okay, something like this, we will think like this way. Okay, but here guys, there is a catch. Okay, the catch is guys, if you are applying the brake, if you are applying the brake, there is a possibility that this train might get stopped before what, this 1 minute only. Okay, it might get stopped what, before 1 minute only. So if it is getting stopped 1 minute only, like before 1 minute, then guys, it is not going to move after that na. So it is not going to move after that. So it means it might be possible that what we are calculating is either overestimation or the underestimation. Okay, that is the possibility. So let's see that guys actually when it is going to get stopped. Okay, so that's why when the student does this problem, they find that this is a very simple problem and then they do this mistake. Okay, so that's why guys here the catch you have to understand. The catch is what is that if you see, let's find out guys when the velocity is going to be 0. So v is equal to what, u plus at. So guys final velocity is going to be 0. U is given how much guys, 15. So 15 divided by 0.3 is equal to what guys, t, which is equal to what, which is equal to 50 second. So it means what guys, it means the particle has, or the train has already stopped guys at what, at 50 second. So it means for the next 10 second it is going to be at rest only. Okay, it is not going to move. I hope you're getting my point. Okay, so in this case, what is going to happen? What is going to happen, guys? So if you see here, the thing is that this, if we take this as a what, guys, our position of the you can say the train. Okay, initially, so it will move how much? It will move some distance and then it will stop. Okay, guys, and the time that it will take effectively is what, only 50 seconds. The next 10 seconds it is not going to move. So this calculation is going to lead us to what, a wrong estimation. Okay, the wrong calculation, not wrong calculation guys, but wrong estimation that where it would be. Okay, so first we have to check this thing that this velocity is how much guys, it is, sorry, the time that it is taking to get stopped is only 50 seconds. Okay, so with this idea guys, what we can say now, that uh, s is equal to what guys, now ut plus half at square. So guys, if I put the values now, so what I'll get, s is equal to, u is how much guys, initially 15, and this is what, 50, and then of course guys retardation is happening, so half into a is how much guys, a is uh, a is what guys, a is given how much, a is given 0.3, and t is what guys, 50 into 50. So guys, if we solve now, what we will get, we will get, this is 750, and this is what guys, this is 25. So guys, this will become uh, how much guys, this will be 3 into 5 into 25, which is how much, 15. So 750 minus how much guys, 15 into 25. So 5 7, so 15 into 2 30, 30 into 375. So guys, this will become how much, this will become 5 4, so 7, and then 6 3, so 375 guys. Okay, so the right location should be what guys, how much it has been displaced, 375 it has been displaced, and then guys what, it is going to be stopped. Okay, so displacement happened is how much guys, 375 meter. Here guys, what we were would be claiming that it has moved 400 meter, and the distance would be what guys, 40 meter from here. Okay, but that is guys what, that is a wrong answer. It has only moved what, 375 here, and the position of the block or position of the train guys in this case would be how much, it would be simply 400 minus 375, and the answer would come how much guys, that is 25 25 centimeter. Okay guys, 25 centimeter. Here guys, what we had gotten, we had gotten that it was 360 only, means it means actually what has happened, if you try to understand here guys, that the particle has gone, according to this calculation guys, according to this calculation, the particle has gone and the return should happen, and this would be what guys, displacement. Okay, but guys, you tell me that if you apply the brake, does the particle also like come back? Okay, like if you apply the brakes on a car guys, does it is going to reverse back if the velocity becomes 0 and then it will come back? No, this is not going to happen. So of course guys, it is only going to move up to this and then it is going to stop. Okay, so this analysis that we had done it using this guys is going to be what, wrong. Now the very like you can say uh, burning question that should come in our mind, that how on the earth we will get this idea that the particle is getting stopped at 50 seconds. Okay, particle is getting stopped at 50 seconds, because if we will see this problem, we will automatically just run on what, this calculation that we are having in front of here, and then we will just solve and we will give the answer. and maybe that would be the first option given in the options if it is given to you. Okay. So how do we get this idea that this would be what answer? Okay, so guys, this is, I am leaving on you to think about. Okay, I will give you the idea or the reasoning behind it, that how I have gotten this idea that this is the reason, and that's why we should approach this question in this way that I have discussed below. Okay, that I will discuss in the next question. Okay, when I will be discussing the 1.3, at that time guys, I'll discuss that why I have done this thing. Okay, why I have done this thing instead of guys what, doing this thing. I have shown you the mistake that the student does. Okay, but how you will get this idea directly, that why this is the way that we should approach. Okay, how we should approach this question, that we have to think about. Okay, so if you get the idea, please put that thing in the comment. Okay, and otherwise in the next lecture or in the next problem solving discussion, I'll discuss that my insights, that how I have came to how I have come to this idea that I had discussed below. Okay, so that's it guys. Okay, I'll see you in the next video.